Hey guys, welcome to another video for pre-calculus. In this video we're going to be going over 10.3 geometric sequences and series, and I'll be working out problems 1, 3, 5, 10, and 12. So let's go ahead and get started. Alright guys, so starting off on 10.3, we're looking at number 1. We're being given this list of ratios, or the sequence of terms here, negative 1/4, half, and then negative 1. And we're being asked to find the common ratio, and then to find the next three terms. So yeah, and then that's it. So let's go ahead and get started. So what I'm going to do here is I'm going to show you how to find a geometric sequence when you're giving a list of terms. So here are my three terms, okay? And so this is my term 1, my second term, and then my third term. So to find the ratio, the common ratio, what you want to do is you want to divide the second term by the first term. And then to find if you want to confirm this ratio, you can divide the third term by the second term. So divide the following term by its preceding term, and then you'll find the ratio. But you only really need to do this once. So my A2 is half, right? And then my first term is negative 1/4. So as you know, the rules for multiplying or dividing fractions, I will multiply by the reciprocal. And then I can simplify here. That's 1, and that gives me 2. Okay, and so I'm ending with negative 2. And this is my common ratio, so I've just figured that part out. So now that I have my common ratio, I can actually use this ratio now to find the rest of my terms. So I multiply my third term, which is negative 3. I'm sorry, my A3 is negative 1. So I multiply that by negative 2, and that gives me a positive 2. And that is my A4. And to find my fifth term, same thing. So I want to multiply my fourth term, 2, by a negative 2, my common ratio, right? So here are my common ratios. And so I multiply my fourth term by my common ratio, and I end up with negative 4. And this equals my fifth term. And I can just keep going on and on. So my fifth term is negative 4, multiplied by my common ratio, negative 2, and I end up with a positive 8. And that equals my sixth term. Okay? So pretty straightforward, nothing much to it. Let's work this out again on a different problem. So I have 0.5, 0.75, and 1.125. And then I want to find my next three terms and my common ratio. So just like before, I want to multiply my second term by my first, punch that into my calculator or mental method, and I end up with 1.5. And this is now my common ratio here, right? So recall that I did my second term divided by my first term to find my common ratio. So now I can use this common ratio and multiply my preceding term. So I want to find my fourth term, so then I multiply my third term right here, right? Multiply the third term by my common ratio, and I end up with 16875, and this is my fourth term. And if I want to find my fifth term, I multiply my A4 times my ratio, which is 16875 multiplied by 1.5, and then that will give me 253,125, right? So I'm doing a different color. So this is my fifth term. Yes? Let's do one more. Why not? So to find my sixth term, I multiply my fifth term by my ratio, and my fifth term, I know what that value is, 3125 multiplied by 1.5, and then I end up with 3796875. And that is the value of my sixth term, right? And so once again, I am looking for the, I'm finding the common ratio and the terms for a geometric sequence. So when I'm saying geometric sequence, I know now that I'm diving into multiplication and division. All right, so let's do one more problem like this. I have 2x, 10x, and 50x. So now what do I do? Well, it's no different. Same thing. Same thing. So I do my a2 divided by my a1, which is 10x divided by 2x gives me 5. And there it is. That's my common ratio. So just like before, if I want to find my preceding terms, my fourth term, I will do my third term times my ratio, which is 50x times 5, and that'll lend me 250x. And that is the value of my fourth term. So one more time, to find my fifth term, I multiply my fourth term by my ratio, which is 250x multiplied by 5. That will give me 1250x. And that's that. That's that concept right there. So that's finding my common ratio and my next three terms in my geometric sequence. Now you'll be given problems like in number 10 where you'll be asked to find the explicit formula and also the recursive formula, right? And this is for finding my explicit formula and recursive formula for finding the nth term of each geometric sequence. All right, so let's see how this plays out in the problems here. So if you're being given a list like this, 36, 12, and 4, and you're being asked to find these formulas for this geometric sequence, just like before, I want to find my common ratio. So you know how to do that already. My a2 divided by my a1. That's 36 divided by 12. And that's going to lend me 1/3, right? So there's my r. So let me store this right here. There's my r, right? Okay, so to find my explicit formula, you know your a1, your first term, that's 36. And you know your r, that's 1/3. And this is the explicit formula and for finding the nth term, right? So to find my nth term, my a to the n, I use the formula a to the 1 times my r raised to the n minus 1 power. Okay? So now the question is, what do I have here to plug in? So I notice here the different terms I have. I have my first term, I have my r, and then I have it raised to a power of n minus 1, and then I have my a to the n. Now the a to the n is a term that you're not going to know. That's the one that you want to find. So it's going to be a to the n equals, and then what's my first term? 36. And then you're going to know your r, which is 1/3. And again, you don't know your n, right? This term right here, you don't know. That's the one that you want to find. So that's the key to this. And so it's found right here. So it's going to be whatever your term you want to find minus 1. So let's say I want to find my 70th term. Then it's going to be 36 times 1/3 raised to the 70th term. So to find my 70th term, it'll be 70 minus 1. So it'll be 36 times 1/3 to the 69th power. And then that will help me find my 70th term. Okay, and that's my explicit formula. So now to find my recursive formula, because with my explicit formula, remember, I don't need to know any preceding values. I can just jump right into whatever I want to find. But with the recursive formula, I need the value of the previous number. So that equation is a little bit different. So if you recall with the recursive formula, I need to first state what my first term is. My a1 is 36, right? And then my formula will be written as a to the n equals 1/3, okay? 1/3, and then indicate the next term, which will be a minus 1. And that's going to be that formula. So this represents my r, and then this represents my next term. right? So recall, I can't find my a to the 2 unless I know my a to the 1, right? And I can't find my a to the third if I don't know my a to the 2. That's the nature of the recursive formula, and this will be that general equation that you're going to see repeated again in the next problem. So let's work out the last problem that I mentioned, number 12. Okay, so with number 12, let me reduce the size of this. With number 12, I'm given the list of -2, 10, and -50. So again, I want to find that common ratio. So it'll be 10 divided by -2. My common ratio is -5. There it is, -5. So with the explicit, remember this is the formula that will help me find any term that I want. I can skip around from 4th term to the 10th to the 50th, 79th, and so on. So this formula will be written in the general term is a to the n, whatever term I want, times my first term, right, multiplied by my difference raised to the n minus 1 power. So what's my first term? My a to the 1 I know equals -2. My r I know equals -5. And that's it. That's my formula. So it'll be whatever term I want to find will equal my first term times my difference raised to the n minus 1. So if I want to find my 100th term, I can put 100. If I want to find my 20th term, I can put n equals 20, and then I can find the value of that term. And now for the recursive formula, recall again that equation. I need to mention my first term, right? Indicate the first term, the value, which is -2. And then to find the next term, it'll be my difference times whatever my next term is. And that's that. So this is my r, and then this value will represent the value of my next term. Right? So let's just work this out so you can see how it plays out. So let's say I want to find my second term. So then my a to the 2 will be -5 times a2 minus 1, right? So that'll be -5 times a to the 1. So the -5, and what's my a to the 1? But -2. And the value of that is +10. So a to the 2 is +10. Now, what if I want to find my third term? Let me do that in a different color. Let's say I want to find my third term. So the equation is my r times my a, my third term, minus 1. So that's going to be -5 times my a to the 2. And I know that value, a to the 2 is this value. So it's -5 times 10, which gives me -50. And that's what a to the third equals. And then my second term. And I already know what my first term is. So I have, let me write that down. I have -2, 10, and -50. So let's confirm that up here. Yep, and here it is. -2, 10, and 50. Just as it was given in my original formula. Okay, well, that does it for this video for 10.3 Geometric Sequences and Series. Thanks for watching. I hope this helped, and good luck in your studying.